The mark scheme for this question 1 then. Define the term enthalpy of lattice formation. So, enthalpy change or heat energy change when 1 mole of solid ionic compound is formed from its gaseous ions. Now, I didn't say enthalpy change, I said energy change. Does it accept that? Allow enthalpy change? Oh, that's a terrible mistake. What am I saying about knowing your definitions? I put energy instead of enthalpy. So, all these underlined ones, enthalpy change, 1 mole of solid ionic compound or 1 mole of solid ionic lattice is formed from gaseous ions. I think I've got 1 mark there for the gaseous ions bit. Or heat energy change. I mean, I've said energy change. I mean, you know what? That's just something to fix for next time. So in terms of my definition, I need to make sure that I say enthalpy change, not energy change. So that's going to be a note following my analysis or my kind of marking of this paper. So a bit annoying there. Not a good start at all. Okay, calculation then. Lattice dissociation energy. So you get 1 mark for laying out your calculation here, and that gives me plus. Oh, see what I did, I flipped it round and I got minus 869. But if you did it like, you know, kind of rearranging it in a different way, you ended up with plus 869 like in the mark scheme, you got to realize that this is lattice enthalpy of formation and you get minus 869. Ooh, I should have put my mark, my answer down there. I didn't see that, but that's probably because I'm using the iPad, but there we go. Any additional guidance on there? Oh, if you wrote 1 plus 869, you do get 1 mark, but you know what? That's just detail there, making sure it's minus. Question 1.3, oh, the ionic model question. So AgI contains covalent character. Done. Forces or bonds holding the lattice together are stronger. So the causes the attraction between Ag plus and I minus ions to be stronger. Done. I even went and said a little bit more. Okay, so what else are we saying? For M1, allow the following. Not completely ionic. Ions are not spherical. Ions are distorted. Some covalent bonding. You could have said those instead of covalent character. Ignore covalent bonds are stronger than ionic bonds. That's not true, technically speaking. No mention to electronegativity or energy needed to be mentioned there. It's just in terms of strength of forces. How do we identify the presence of iodide ions? Well, that is silver nitrate and a yellow precipitate. Done. Oh, or we could have had this kind of displacement reaction with chlorine or bromine to give a brown solution or a black precipitate. So what we could have done, ignore any reference to ammonia, acidified, nitric acid, sulfuric acid. So basically they're just after the main reagent here. I mean, we tend to use acidified silver nitrate just in case there's anything else in there using nitric acid, but you know what, they're just after the reagent. So I got 7 out of 8 on that, which is a little bit annoying. So enthalpy instead of energy. I should have known that because you know what, the word enthalpy is in the question. So yeah, lesson learned on that one. I will not do that again.